Okay, hi everybody. So for this question here, we're going to solve the following trigonometric equation on the domain 0 to 2 pi. And we get negative 2 sine of 2x cosine of 2x equals 0. And this is similar to a previous question that I've looked over, um, but I'm just going to extend it in a kind of a different direction here. Again, there is a temptation to look at this and say, well, wait a minute. I see 2 sine of x cosine of x. Shouldn't I be using my identity and making that equal to the sine of 2x? Like I could make this a little bit more complicated. I could take what's sitting here right now and make this into 2 sine of 2 times the 2x that I'm seeing there. But actually in this case, that is going to make this a little bit harder than I want. I actually don't want to do that. What I want to notice here is that I've got a product and the answer is 0. So either the sine of 2x is equal to 0 or the cosine of 2x is equal to 0. I want to focus my attention on those. Now, this is very similar to another question that I've done. The reason why this one here is I want to show you what happens with this 2x, okay? A lot of times when I solve this, what I'm going to solve for first of all is I'm just going to put an a there. Okay, I'm just going to put a different variable, and I'll do the same thing for both these. I'm just going to put a different variable there for the beginning here. There are two levels to this when I'm at this point here. There is a trigonometric level and then an algebraic level. And the algebraic level in this case is inside the trig. So I'm going to get to that last. So just for the time being, I'm going to ignore the fact that there's a 2x there. I'm just going to solve for the angle. Now, we've looked at this before. I know that I'm looking at, first of all, one rotation here. But when I look at the unit circle, I remember that sine is associated with the y coordinate. And the y coordinate goes to 0 on the x-axis. So that means that my a value here, okay, is either going to be 0 or pi, okay? Now, because I've got a 2x in there, that 2, if you think back to, let's say, your unit on transformations of functions, I know that the 2 here is going to affect the period of the sign. It's going to cause this thing to repeat a little bit quicker here. So when I answer a question like this, what I'm actually going to do is I'm going to come up with the general form, okay? So I'm actually going to look at this in a little bit differently. I know that a is going to be multiples of pi, where n is an element of the integers. So for right now, I'm not going to worry about the 0 to 2 pi that I see in the original question here. I'm going to solve this one in general. So what I'm saying here is that sine of a goes to 0 every time the angle is a multiple of pi, which puts it on the x-axis here. Now, the reason I'm going to do that is I am now going to replace that a with my 2x. Okay. And now I'm going to divide by 2 to get x here. So this is going to be n pi over 2, where n is an element of the integers. What I've got here is a little engine for creating all possible solutions to this. All I have to do is start plugging in integers. Now is when I consider my domain. Well, my domain was 0 to 2 pi. So if I plug 0 in, my first integer there, because I don't want to go into negative angles here, but if I plug 0 in for n, I get 0 times pi over 2, and I get 0. If I plug 1 in, I get 1 times pi over 2. If I plug 2 in, I'm going to get 2 pi over 2, which is just pi. If you plug 3 in, you're going to get 3 pi over 2, and I'm still good. But as soon as you plug in 4, I will get 2 pi. And if you look back at the original domain, that's not included, and so I stop. Though that's the set of angles that I'm going to get from that first answer there. That first function, sine of 2x. Now I change my attention to cosine. Cosine of a equals 0. But I'm going to do the same thing. Cosine goes to 0. Cosine is associated with the x coordinate. So it's going to go to 0 on the y-axis where the x coordinate is 0. In general, that means my a value here is going to be pi over 2 It's going to start at pi over 2, and then it's going to repeat every pi. Now, I am assuming a bit of familiarity with trigonometry here. I'm hoping that this is just ringing a bell. This is not a great place to be learning this for the first time. This is basically just reviewing this. So there's my general solution for that. Now I'm going to replace a with 2x. Okay. Just like we did before, I'm going to solve for x. So this is now going to be pi over 2 divided by 2 is going to be pi over 4 plus n pi over 2, where n is an element of the integers. And now again, I have a little engine for producing all of the possible solutions that I want. I don't want negative angles. I'm not going to plug in negative values into this for n, because as soon as I do, I'm going to get negative angles here. But I can start by plugging in a 0, and that will get me pi over 4. Okay. If I let n go to 1, I'm going to get pi over 4 plus pi over 2. Just a little bit of arithmetic there, and you'll see that that's 3 pi over 4. If I let n be 2, it's going to be basically pi over 4 plus pi, which is 5 pi over 4. If I add 3 pi over 2 to pi over 4, I'm going to get 7 pi over 4. And if you do that one more time, you'll see right away that the answer you're going to get is too big. Okay, I'm going to add pi over 4 to 2 pi, and that's too big here. So those are all the solutions that I'm going to get. There's a lot going on in this problem. It's a really good question.